So hello students. So today we are going to learn about chapter number 2 of class 9, that is polynomials part 7. Okay, so today we are going to learn about algebraic identities. Okay, this algebraic identities you have already learned in class 8. Okay, today we are going to just revise that algebraic identities and we are going to solve some extra examples on this algebraic identities means, in short, we can say that we are making some formulas. Okay, so now let us see some of the identities. Okay, so here we have 4 different identities which we are going to learn today. Okay, now first identity is that x plus y bracket square is equal to x square plus 2xy plus y square. Okay, now in other words we can say that first term plus second term bracket square equals to first term square plus 2 into first term into second term plus second term square. Now how we got this formula? Okay, so let us see the derivation of this formula. So now x plus y bracket square means x plus y is multiplied 2 times. Okay, so we have written it as x plus y into x plus y. Now what will happen in next step? The first term of this bracket will multiply to this full bracket, that is to each and every term of this bracket. So we have written here x into x plus y. Now second term of this bracket will multiply to each and every term of this second bracket. So we have written here y in bracket x plus y. Okay, now this x, first it will multiply with x, then it will multiply with y. So x into x, x square, x into y, xy. Then again this y will multiply to x, so y into x will become xy, y into y will become y square. Now it can be seen that these both are like terms, okay, and repeating itself. Okay, so we can write x square only one time. Now since they are like, so we can add or subtract the like terms. So xy plus xy will become 2xy. Okay, so in this way finally we are getting, therefore we can write x plus y bracket square equals to x square plus 2xy plus y square. Okay, so here what we have done, we have formed an identity, that is a formula. Okay, now in this way we can find this remaining 3 also. Okay, that is x minus y bracket square, x square minus y square, x plus a, x plus b. Okay, so now let us solve some examples based on these identities. Okay, before solving example, let us revise this second identity. X minus y bracket square means first term minus second term bracket square. So how it can be written as x square minus 2xy plus y square. Now suppose there are two terms, first term square minus second term square. So at that time what we will do, we will add the first we will add the two terms, and then in the second bracket we will subtract the two terms. Okay, then suppose if a condition is there that only one of the term is repeating itself and the other terms are different, that is x plus a, x plus b. During such time the term which is repeating, we are writing the square of that term, that is x square plus, now which are not repeating, we are adding it and multiplying it with the repeating term plus multiplication of the non-repeating terms. Okay, so when you will solve examples, you may easily learn these formulas. Okay, now let us solve some examples based on this one. So now here we have our first example, that is use suitable identities to find the following products. Okay, so let us solve first example. First example is given as x plus 4, x plus 10. Okay, now solution equals to, now it can be seen that the first term is repeating and the second terms are different. So which identity we can use over here? Yes, we have to make use of this fourth identity, that is x plus a, x plus b. What is it? It is first term square. So what we will do, our first term is x. Okay, this x, so we will write here x square, then plus what is given, second term of both the brackets will add each other. So what are the second terms? 4 and 10. So what we will do here, 4 plus 10. Then they are multiplied by what? With the first term. So who is our first term over here? X, or common term x. Okay, then plus, now this a into b, that is both second terms, will multiply each other. So what you have to write here? Plus 4 into, that will be 10. Now on next step, what you will get? X square plus, now this we can add, 4 plus 10 will become 14x plus 4 tens are, so that is 40. Okay, now further we cannot do anything, so this is our final answer. So here what we have done, by using an identity we have written the expanded form. Is it clear? Now let us solve. So in this way you people have to solve this remaining all examples. Okay, so now let us solve next type of example. Now here it is given, evaluate the following products. Okay, before that let me tell you that which formula where you have to use. Now here also first terms are repeating, so you can make use of fourth identity. Here also first terms are repeating, so you can make use of fourth identity. Now here first term, second term, again same terms are repeated but signs are different, so here you can make use of which identity? Yes, third identity. Okay, here also same condition you have to decide. Okay, so now I think it will be easy for you to write it. Okay, now one more method, we can solve this example by one more method. I am writing here or. Okay, now by another method, what you will do? X plus 4, x plus 10. Now this is our general method. What we are doing, we are keeping this first term and multiplying with this full bracket. So what you will get? X into x plus 10. Then we are writing the second term multiplying with this full bracket. So plus 4 into bracket x plus 10 equals to, now this x will first multiply with x, then it will multiply with 10. So x into x, you will get x square plus 10x. Similarly, this 4 will first multiply with x, then it will multiply with 10. So 4 into x, you will get 4x plus 4 tens are 40. Now you can see that these are like terms, so we can add it. So in next step, what you will get? X square plus 14x plus 40. So same answer you are getting in both the conditions. Okay, so it depends on you. If you are able to memorize these formulas, identities, you should go by this method. If not, then this one is our general regular method. Okay, now let us solve some different type of example. Now here it is given that evaluate the following products without multiplying it directly. So now we are given with the numbers, but we are not supposed to multiply it directly. So let us solve it. Solution. Now 103 into 107 equals to, now this 103, we have to write these numbers in such a way that either one of the number must be repeating. So 103 can be written as 100 plus 3, and the second number can be written as 107 can be written as 100 plus 7. Now it has become an identity. Which identity? First term is repeating, so that is our identity number. Yes, so that is our identity number 4. That is first term plus second term, again first term is repeating plus next term. Okay, so by using this identity we are going to solve this one. Now what we are going to do, let me maximize this one. Okay, so now what we will do, first term square. So who is our first term? 100 square. Okay, let me make it more easy for you. I am just highlighting the first term with this green color and the remaining terms with this red color, red and blue color. These are not common. Now what I have to do next, now here it is given the uncommon. So which are the uncommon? 3, 7. We have to add it. Okay, so plus 3 plus 7, then we have to multiply it what? With the repeating term. Okay, so that is 100 plus, now next step what is there? Product of the uncommon, so that is 3 into 7. So now next step, now 100 square means you will get 10,000. Okay, plus 3 plus 7, again it is 10. Okay, so you will get 10 multiplied by 100 plus 3 sevens are 21, so that equals to 10,000 plus, now again 100 into 10 will become 1000 plus 21. So what will be our answer? Now 1 plus 0 will become 1. The next 2 plus 0 will become 2, and next now 0 plus 0, so it will become 0. Next step, 1 plus 0 will become 1, and finally our 1. So what is our final answer? So our final answer is 1102, 1. Okay, so in this way now you people have to solve the remaining examples. Okay, so I'm just minimizing this formulas part. Okay, so that you can copy that remaining examples. Okay, now you people have to solve the second one and third one. Now 95 into 96, this can be written as, we have to make it an easy number. We can write it as 90 plus 5 also and 90 plus 6, but it will be a little bit difficult one. It is better to write this one as 100 minus 5, 100 minus 4. Okay, this one as, now this can be written as 100 plus 4, 100 minus 4. Now you have to decide, if you are writing this one as 100 plus 4, 100 minus 4, then which amongst these 4 identity we have to use. Okay, now let us solve next example. Now again here it is given that factorize the following using appropriate identities. Means here it is given in expanded form. Some of the examples we have to write it in factor form. Expanded means in term forms. Okay, now let us consider first example. So we are given with 9x square plus 6xy plus y square. Okay, so solution equals to, now whenever the terms we are supposed to factorize the given terms, check the terms properly. Now here first term, it is a perfect square. The last term, it is also a perfect square. So this 9x square can be written as 3x bracket square, where 3 square means 9 and x square means x. Then we will decide plus here, then now we will decide the what is the next last term. So it is also perfect, that is square of y. So I am writing it in this way, y square. Now in between, okay, now check whether we can write this one in terms of this first term and second term or not. So yes, we can split it as 2 into 3x means our first term, and into y means our second term. So now let us confirm whether we are when we are multiplying this one, are we getting this or not. So 2 3s are 6, x into y, xy. So yes, so we have just written this one in factor form. Okay, now if you look at this formula, this seems to be an identity. Which identity? First term square plus 2 into first term into second term. I am just highlighting this one. This is our first term, this is also our first term. Okay, and this one is our second term, this one is our second term. So it seems to be of the form first term square plus 2 into first term into second term plus second term square. Now if you look at this identities part, so it is similar to Okay, now you people decide it is similar to which one? First term square plus 2 into first term into second term, so it is similar to first identity. Now instead of this one, so this one is expanded form, instead of this one, can we write it as first term plus second term bracket square? Yes, obviously. So now further what we will write? First term, so now what is our first term? 3x plus second term, that is y, so plus y bracket square equals to 3x plus y, 3x plus y. So now here what we have done, we have written this one in factorized form, factored form. In other words, we can say that we have factorized this one. Okay, so hope you must have understood this much. So this much is enough for today. Thank you, have a nice day. Okay, your homework is these all questions whichever you can see in the videos. Okay, thank you, have a nice day.